Welcome. Let's solve Leetcode 2558. Take gifts from the richest pile. Okay, so let's go over this problem statement they provide us. You are given an integer array gifts denoting the number of gifts in various piles. Every second you do the following. Choose the pile with the maximum number of gifts. So hopefully whenever something like max or minimum is brought up, in your mind you think of a data structure that will, what's the word, assist us with this type of operation. So we want a data structure that will provide us the maximum element. And the most obvious data structure that should come to mind is a heap. However, another methodology that should pop up into your mind is maybe sorting. So I just wanted to go over that piece of information. At least that's something that pops into my mind when I see the word maximum. If there is more than one pile with the maximum number of gifts, choose any. Leave behind the floor of the square root of the number of gifts in the pile. Take the rest of the gifts. Return the number of gifts remaining after k seconds. Okay, great. So let's go over, or let's walk through this example here. So they give us a gifts list here with 5 elements, and they tell us we can remove or perform 4 operations. So the maximum there is 100. So the last pile is chosen and 10 gifts are left behind. So remember, they tell us to leave behind the floor of the square root of the number of gifts. So the square root of 100 is 10, so we leave 10 behind. Next, the biggest value would be 64. That means we leave the square root of 8. Next, so remember, we're allowed to do this 4 times. We remove 25 and place back 5. And lastly, we remove 9 and return 3. These would be the remaining elements, and they ask us to sum them up, and so the return value is 29. Okay, so that's basically the essence of the problem. We don't need to go over example 2. It's basically the same thing. So now let's go over how we'll do it. So one of the things that comes into my mind is we'll always want to know the maximum element. So a good data structure that will help us here is the usage of a heap. And Python comes with a heap module. And so what we'll want to do, though, in this scenario is we'll want to convert whatever they give us, and we'll perform what's called heapify. We'll convert this to a heap using that method provided by the heap queue module. So let's do that. So we'll say, okay, so heapify g. Now I am going to print out something here. I'm going to, just for educational purpose, I'm just going to return maybe 4, and I want us to print out g before and g afterwards. Okay, let's print it out. Let's maybe move this over. Okay, so let's go over this here. So this was the heap before, and this is the heap afterwards. Sorry, I want to go over one more thing. So let's actually maybe minimize this. And I want to print out the first element here, so let's print out g, and let's print out the first element and g, and then we'll print out the first element and g after the heapify is performed. So before, the first element is 25. However, after we perform the heapify operation, the first element is 24. And you notice the first element is 4, which happens to be the smallest element. In actuality, we want the biggest element. If you recall, that was the rules that they wanted. They tell us to pull out the biggest element and return the square root of that value. So we'll use the heap, but we want to adjust it. So what we'll do is we'll take all of these values and make them negative. So let's do that again. So what we'll do first is we'll change G. So we'll say, okay, for every element in G, we'll change it to its negative. And we'll set this equal to G. So G is now, we'll print it out, and then let's display what happens. Okay, so great. So this was G. So remember, this was the original array they give us, or list they give us, and we converted all of them to negatives. But now notice how after we performed the heapify here, now the first element of G is negative 100. So this is good for us because now all we need to do is just take the negative of that, and we can use this to assist us in finding the solution for this problem. Okay, so let's do that. So we'll remove all this now. We don't need this anymore. We don't need this anymore. And what we'll do is we'll perform this operation k times. So for range k. So we don't really need the index. We want to perform the operation k times. So they tell us to always remove the smallest, well, the biggest element, but for us it's the smallest element. So let's go over this. So we use heap pop, and we're going to pop it from G. And remember now, if we pop this will give us negative 100, but we need to be aware of that. Remember, we purposely made it negative, so we'll need to take the negative of that, and that'll be our what do we call it? We'll just call that our element. I'm not sure. Let me see. We'll call it little g. Yeah, call it little g. So we can print it out now. How about that? Let's print g. And so let's run it. So 4, we want to remove 4 of the biggest elements. So 4, 100, 64, 25, 9. Perfect. So this is going along. This is going great. But they tell us to leave behind the floor of the square root of the number of gifts in that pile. So we take out the maximum number of gifts, which was 100, but then we have to leave back 10 in this case. So let's do that. So what we're going to do is we're going to use now heap push G, and now we'll take the square root. So G to the 0.5 power, and they use, what did they say, the floor? So we can just, the floor, so that means we'll just use the integer division, so that's fine. We don't need to use any special math functions. We can just use int. Now remember though, we need to always push in the negative version of that. So we'll just place a negative here. Okay, great. So consider this. We have done this operation k times as they have asked of us. That says every second you do the following. Return the number of gifts remaining after the k seconds. Okay, so what we've done so far is we removed 100 and we put back 10. We removed 64, we put back 8. We removed 25 and we put back 5. However though, we would have been left with 9, 4, 8, and but remember though, we have a 10 still. So sorry, So yeah, sorry. So remember, we took out the 100 and we put back 10, and then we're left with 25, 64, 9 and 4. Is that right? 26, 25, 64, 9 and 4. Yes. And then we took out the 64 and we put back 8. That's 2. Then number 3, we took out the 25 and we put in a 5. That's 1, 2, 3, and then we need to do one more. So the square root of 10 is 3 point something. So then we just end up with a 3 here, which is what we have here. So remember that they tell us to return the number of gifts remaining after k seconds. So let's see what we have here. So let's print out what we have remaining. So let's print G out. So G looks like this now. So what we can do now is all we need to do is add them up and take the inverse of that. We don't need to loop through them and convert it. We can just add them up and take the reverse of it. So we can just do something real simple. We can say, okay, we'll just take the sum of G and make it the opposite of that, and we'll return that, and we are done. So let's look at that real quick. All right, looks beautiful. Let's submit it. Very good, very good. So even though it's only 63%, it's only 4 milliseconds. We can't do too much better than that. I mean, so we shouldn't feel bad about ourselves because we're at 63%. It's just well, there you go. My point is, there isn't much to do for this problem. It's some very, well, at least I think I tried to make it simple. That's part of my whole approach to coding, is that I like to make it simple because I'm not good at difficult tasks. I like to simplify them. And I think this is very clean, and from the result, it's the computer agrees. It's very fast and simple, not too much complication going on. And there you have it. If you found this in any way educational or helpful, please consider liking or subscribing. Have a wonderful day. Take care of yourselves.